So in order to prepare ourselves for solving trig equations, I want to do a little investigation with you. So if you can pause the video and use your calculator to find what the cosine is of these three angles. Hopefully, if your calculator is in the correct mode, you will see that each of these is equal to 0.93969, and it goes on and on. So they're all the same. And why is that? Why can three different angles provide the exact same cos ratio? Well, the answer is in the reference angle. So if we graph the first one, which is 20 degrees, 20 degrees would be in the first quadrant, and it would, if you make it this triangle with the x-axis, then we know the reference angle is 20 degrees in quadrant 1. 340 degrees is in the fourth quadrant, so it is going all the way around nearly to 360, and in the fourth quadrant. It is going to be also have a reference angle of 20 degrees. So it's the same size triangle that is created with the x-axis for 340 degrees as is with 20 degrees. And in both of these quadrants, all scientists take calculus, both of these have the cosine is positive. Here in this case, remember, all of them are positive, and in this quadrant 4, the cosine is positive. So not only is the size of the cosine ratio the same, but also the sign of the ratio. Now let's take a look at the last one, which was 380 degrees. That means you're going 360 plus another 20 degrees, and you land at exactly, it's a coterminal angle with the first one, and so will produce the same ratio. So there are many answers, there's many angles that will provide the same ratio, and that doesn't matter if we talk about sine, cosine, or tangent. So now let's use that knowledge to help us solve a trig equation. Notice it's an equation and we're solving for the unknown, and the unknown in this case is the angle. So we're expecting an angle in degrees. Your calculator should be set in degrees, and we're expecting an answer between 0 and 360 degrees. That's what this states here. This is called the domain restriction. And we want to make sure that our final answers, and I say that plural, are between 0 and 360 degrees. So let's start by using this negative here as a clue to where the answers or angles are going to be. The cosine is negative. So if we use they're all positive here. That means that since cosine is negative, we're not going to be in that quadrant. Here the sine is positive, but the cosine is negative, so an answer is possible in this one. In this quadrant here, it's the t quadrant, which means tan is positive and cosine is negative, so that is also a possibility. And here that's the c quadrant, which is cosine positive, so we know that this one is not a possibility. So we've got two places where there is going to be an answer that gives the ratio that is negative. So I'm going to draw this again, and I know that one answer is going to be in this quadrant. And the angle I'm eventually looking for is this one right here. So now I'm going to pick up my calculator to give me a hand, and since the cosine of theta equals -3/4, I need to undo this or instruction or do the inverse of this instruction. So to isolate theta. So angle theta equals the inverse cos of -3/4. And with the help of your calculator, you should get an answer of 138.6 degrees. Now that answer here we know is in the second quadrant, so that must be referring to 138.6 degrees. So one of our answers is we've just figured out. Now there is a second answer, and the second answer is sitting in this quadrant. And the characteristic of that answer is it's the same reference angle. So this angle and this angle here are going to be the same. So our first job is to find the reference angle. So the reference angle is 180 degrees minus 138.6, which is 41.4 degrees. So that's finding this little sliver here, that's 41.4 degrees. We know that these two angles are the same, so this one is also 41.4 degrees. And now we go from angles in standard position, so we're going to measure starting from here, going counterclockwise all the way to this second answer. So our second answer is going to 180 degrees plus this extra bit. So 180 degrees plus 41.4 degrees. So angle theta is 221.4 degrees. So I have two answers that will give me a cosine trig ratio of -3/4. So let's try this again. We're going to first figure out which quadrants, in which quadrants the tan is negative. Tan is negative in quadrant, well, let's go through them. All is positive, the sine is positive, and the tan must be negative. So there's an answer in quadrant 2. And then there's a second one in quadrant 4, because in this one, the C quadrant, the C is positive and the tan is negative. So I've identified the two places where the tan is negative, and now I use my calculator to help me figure out what the angle actually is. So the tan of theta is -1.5, so we're going to take the inverse tan of both sides, and you should get an answer of -56.3 degrees. Now a negative answer, we don't want a negative answer, we want an answer between 0 and 360. So we need to reinterpret that. -56 degrees, this means an angle that's going counterclockwise, so that must be referring to this angle right here. And that tells you that the reference angle for this problem is 56.3 degrees. And with that reference angle, then you can calculate the angle in standard position, which means going this way all the way around and stopping here. So the first angle is actually 360 degrees minus 56.3 degrees, which is the reference angle, and angle theta is 303.7 degrees. So this is 303.7 degrees. Now we have a second answer there that we need to calculate, this one right here, the blue one going from here to here. How are we going to do that? Well, we're using the reference angle. The reference angle is exactly the same. So in this case, the reference angle is 56.3 degrees, which means the second, or the blue angle, is 180 degrees minus 56.3 degrees, which is 123.7. So let's try this one more time. We're looking for where the sine is negative, and the sine is going to be negative in this quadrant and in this quadrant. Hopefully that part is coming easier for you. We are going to now use our calculator to take the inverse sine. So since the ratio is -1/5, to calculate the angle, we take the inverse sine, or the arc sine, it's sometimes called, of -1/5, and that should give you an answer of a -11.5 degrees. So again, notice that answer here is not positive, and we want an answer between 0 and 360. So this is just our first clue on how to answer the question. It's not the actual answer. The negative indicates that it's a counterclockwise direction, so that means it's referring to this answer right here, and that's 11.5 degrees. So the reference angle is 11.5 degrees. We need to measure all the angles going counterclockwise starting at the x-axis. So this angle here, the green one, is 360 degrees minus 11.5 degrees, which is 348.5 degrees. Now our second angle, the blue one, is going to have the same reference angle. So when we measure it, we go to 180 plus the extra 11.5. So angle theta is 180 degrees plus the 11.5 degrees, which works out to be 191.5 degrees. And just double check that your answers are in between 0 and 360.